Back my bullshit. So, how's it going, everyone? Hoping that everyone is staying safe. But here's your boy coming back at you at the tail end of summer with a little bit of Kubernetes action. This saga began some time ago, so I wanted to install the Spark operator on the Turing Pi V2 cluster that I have. Yet, so lo and behold, so I found out that it was not, the images that it uses were not compatible with the processor architecture that I was running on the machines there. The machines there report ARM V7, and the operator was prepared for Arch 64. So the ARM processor architecture has been released over the years in a version manner. So you have ARM V6, V7, V8, and each subsequent version is backwards compatible. So you have to compile everything, all of your libraries, all of your dynamic libraries, and etc. by ARM version, which leads to a lot of problems. And the Turing Pi V2, so I was running Hypriot on that, which is V7, and I tried to deploy Armbian. I tried to run. And besides that, I was also stuck on ancient Kubernetes, on Kubernetes 17 on that. So deploying Armbian didn't work. Deploying modern Kubernetes didn't work. So it ran super slowly and it was super sluggish. So at some point I just figured, you know what, I'm just going to bite the bullet and I'm going to upgrade, because the Turing Pi V1, that's, you know, an older story now. So there's a Turing Pi V2 now. And Turing Pi V2 allows you to make a cluster of computers with Raspberry Pi CM4 compute modules or the NVIDIA Jetson. There's a bunch of new players in town, actually. Very unfortunately, there's a Raspberry Pi shortage. You can also use the Jetson Nano, or you can also get Turing's own RK1, which is up and coming, right? Since you cannot find compute module 4s in the market, so I finally decided to bite the bullet, and I got the SoQuartz from Pine64. The Turing Pi V2 needs a carrier board for your compute modules. And what's cool about these little guys, that they're designed to be more or less completely compatible with the Raspberry Pi ecosystem. Of course, there's a lot of rough edges, but this has exactly the same connector that the CM4 has. So you can use an adapter, a CM4 adapter, and it just, there we go. And it just snaps into place, and that's it. And now you got it. So, happy to report that the SoQuartz is actually really good, and it works perfectly for me. So there's some reports online of, you know, well, the documentation is deficient, so a lot of the support is provided through really obscure Discord chats, and people are bouncing files around on Discord. All of that is true, but believe me, it is getting a lot better. Not to mention that you can get one of these for $35, and you can actually get them unlike a Raspberry Pi. This is actually starting to become incredibly attractive for the hobbyists, right? All right, so I got that, and the reason why I wanted the Turing Pi V2 is because the Turing Pi V2 has SATA ports. So I'm deciding I'm going fucking big. We go fucking big over here. So let's get a nice, beautiful hard drive, and let's hook it up to that. And I figured, you know what? So okay, I'm also gonna try running Spark on that again. But I said, you know what? I've always wanted a Seedbox, so let's make a Seedbox out of this. And why not? Just for the heck of it, let's actually use Kubernetes. And lo and behold, like, it actually worked out. I'm actually surprised at how easy it actually was. I'm actually surprised at how nice the experience actually was. And so I want to share a little bit with you about how I went through this, how I did this. Edge computing, everyone, which is kind of like a fancy term for just a fucking local computer. Edge computing, right? So step number one, So you take your compute modules. So the adapter has an SD card slot. You take this and you flash your Linux operating system exactly like none of this is too novel. You've probably seen this a million times, but you flash it just as you will flash any other SD card for Raspberry Pis. Let me show you this actually. So Pine64 has a wiki where they link to a distribution of Manjaro ARM, right? That you can download, and this is pre-baked for their machines. So just download this. Well, you may want to get the minimal, because we don't fucking need UIs over here. We don't do UIs over here, bro. Nah, but so I mean, you can get Xphase or a desktop environment included, but I don't need that actually. So just get like the minimal, right? So you get that, and you flash it to your SD cards through the Raspberry Pi imager. Like, this is that simple. And again, if you've done this before, like you've already done this a million times, right? So that's step number one. And after that, once you have your machines flashed, hook them up to the board, place them down on their slots. They click when they're set in place. And I will advise to connect one of them at least to the number 3 port, because the port number 3 has access to the SATA ports. And we're going to use that node to run an NFS server, right? Once your machines are ready and running, so Manjaro SSH into them as root without password, Manjaro will let you in. It will run through a really small series of configuration steps, and then it will reboot, right? So do that, and then once you have that, assign a static IP. You can do IPA, well, IPR if you want it to be more legible, right? And that will show you what's your current IP in your local network and what's the name of the network interface. So Manjaro uses systemd, which is but you know, so you can sudo nano etc systemd network, and then create a file using the name of your network interface, end0 in this case, .network, right? And just enter this. This is that simple again. So with this, you get a static IP. Do that for every machine in your network. So next, since you already hooked up your hard disk to the cluster, SSH into the machine that you have on node 3, and then format your hard drive. fdisk-l will show you what devices are attached to your computer regardless of whether they're formatted or not. In this case, I have dev SDA, but you may have a different kind of convention. Then run makefs.ext4, pointing it to your device. Create a directory to represent your hard drive mount. I chose data on the root, but you may want a different one. And then just add it to your fstaff. Then run mount-a and verify with df that it works out for you. It's that simple. So in this case, so I got it. Then this is where the fun part begins. So we're going to create an NFS server. NFS is a file sharing protocol for local networks. So obviously there's a lot of different networks out there. The most popular one of them is probably Samba. NFS is, I've seen it used a bunch, NAS boxes. So let's just use that, right? I found it to be very solid. So you may want to use a different kind of share, but I think that this works really well for what we're trying to do. So install the NFS utils package, then add this piece of configuration here, which you're looking at in my screen, and add it to your etc exports. So my etc exports is gonna look like this, right? There we go. So that's the configuration for the data mount point. Then enable the NFS server service with system control, run export effects, and check show mount. That's also that simple. And that's gonna be pretty simple. Show mount G local. If you see this, life is good. Then let's move on to the next part. So we already have a cluster with 2 machines running in parallel. Now we're gonna get Kubernetes onto them. For this, we're gonna use K3's Ansible. I'm not gonna cover it again, I already did it in a previous video, but please refer to that. So next, you will create a storage class for your Kubernetes cluster. Storage classes are definitions of ways to do storage, ways to store data that's gonna be persistent. In the Kubernetes world, everything is ephemeral. Pods are ephemeral, so they have ephemeral containers, and the containers can appear or disappear at any given time, or they may multiply or scale up or scale down. You should never regard anything on a container's file system as persistent, because when the kubelet decides that it's time to to do something, like that container may disappear without any warning. To handle persistent storage, then Kubernetes offers abstractions such as the storage class abstraction to define, are you using AWS EBS? Are you using GCP block storage? Are you using etc.? There's many cloud providers and there's many different kinds of storage classes. So you can create a storage class for NFS servers such as ours, right? And that's what we're gonna do. So you create the NFS client storage class with a Helm chart. I install NFS subdir external provisioner. So this is how you install it. Pointed, set. So Helm charts allow for values. So use the nfs.server value using the IP, the static IP of the machine that's running your NFS server. nfs.path, it should point at your mount point, which is data on the root, right? That's what I chose. So that's gonna create a storage class, so which is here. You see that here, right? And then once you have a storage class, so Kubernetes also has the persistent volume and the persistent volume claim abstractions. So persistent volumes are definitions of, so this is something that exists on a disk. And persistent volume claims is, I want this to be present on a container as something that I can use. How exactly? Can many containers read and write at once? Or there's many options to handle control there. Okay, so we'll create a persistent volume and a persistent volume claim to the storage class NFS client, which we already created, right? We're gonna set it to read write many, and it's gonna ask you for, okay, where is the server and what is the path for the NFS share? Then this persistent volume claim is, okay, so I'm gonna take all of that space and I'm gonna make it available for different pods. So we're claiming 4 terabytes too, right? Because that's the size of my disk. So once we have that, so life is good. And you should see that the NFS is bound. You may also see that it's pending until the first consumer pod spins up. And so if you see that, it's also fine. So next, so here's another bit of fun. So we're gonna deploy the Plex chart. So I decided to use case at home Plex chart. So use this to install it to your repos, and then this is the configuration that worked for me. Time zone, an ingress. Do you want the chart to create an ingress for you? Yes, because I want to access this. Host network, persistence.config.enable, and what kind of storage class you want for the config. So K3 creates a storage class called local path by default, which uses this the storage on the actual compute module, the storage here on the SD card. So once you have that, so a very little adjustment that you need to do. So I looked at the optional values on the chart. I didn't find any way to configure it. If you know one, please enlighten me. But the Plex deployment, you should edit that. You can hit edit and you will see the manifest. And here, so you will see an option to configure volume mounts for the path and volumes for the path. So here in volumes, then just add one for your media and point the persistent volume claim to the persistent volume claim that we just created. And this is also gonna point to the media share. So with this, we're just indicating Kubernetes. So that NFS PVC is gonna be available on the dash media path within the containers. So the containers running in a pod, so all of that is an isolated environment, right? But what if you want this to get data from an NFS server running outside of the container? So this is how, with a volume mount, okay? So now we have this. We just edit the deployment, and Helm is gonna reconcile, and that's it. Then finally, I'm gonna use the transmission-OpenVPN Helm chart to deploy the transmission BitTorrent client. Obviously for downloading and torrenting all of my legitimate content and all of my completely legal and legitimate video files. What the fuck? Just ignore that. That was a bad joke. Your internet provider doesn't give a shit if you're torrenting movies, if you're torrenting copyrighted content. They don't give a shit. For what it's worth, they will actually pay you if they could to watch that content, okay? However, there's people whose jobs are to monitor people who are connected to torrents downloading an X movie, let's say Anchorman, for example. So the Anchorman studio has like a bunch of cronies like looking at the clients, and then they subpoena the internet provider to tell you, hey, we saw this IP downloaded at this time, so give them a slap on the wrist. So you may get a letter in a mail telling you, no, don't download, we may find you, we may sue you. When that happens, that's usually an empty threat, but then again, just don't risk it. So if you get a VPN, you can connect to the torrent through a tunnel. That will be a great subject for a video, actually. So I may actually do that at some point. So you connect that through a tunnel, so your IP is effectively masked, so you don't get any warnings, and life is good. And again, so it's not that big of a deal, you know. It's kind of like this exploitative business model, but still, you want to play it right? So install OpenVPN. OpenVPN supports many different VPN providers. You probably already have a VPN provider. If you don't, I use PIA, Private Internet Access. Really, really good. And it's just less than $5 a month. But again, this is compatible with many other providers. And so this has a bunch of configuration options. Let me show you what worked for me. Helm install. So this chart will block traffic on anything that's not a local network, and you override that within the container, and you override that with this environment variable. So you use I pointed all of these, which all of the CIDRs of my Kubernetes. Kubernetes has an internal networking, which is isolated, and you want to find the CIDRs for that. I'm gonna edit it into the video because it's an interesting command, right? But you want to find all of the CIDRs and pass them so they're overridden and traffic is allowed through them. I recommend setting the override DNS flags, OpenVPN options. So this worked for me. I think that you may not necessarily need it, but VPN provider, VPN username, where you want your downloads to land. So I'm gonna point that to the NFS mount on the container. Transmission incomplete there. OpenVPN password. I had problems with a password with symbols. I recommend just going alphanumeric only, but you may want to tinker around with this Helm chart to make it work. Persistent is PVC. Persistent existing claim. I'm pointing it to the PVC that I did. And wait a second. All right. volume system claim. That's BBC then, right? That's BBC, but anyway. Helm has this standard of the values file. So the values file is a way to pass additional configuration, right? And the values file for me, so it ended up looking like this. Let me show you. Where again, so luckily they provide a mechanism to configure what your volume mounts are gonna be, what your volumes are gonna be on the pod, and what mode you want. So just pass that. I had to do that with a YAML file because for some reason, so they had this really weird syntax. So all of these is equivalent to YAML markup, but the syntax is just super buggy and super quirky. So I figured just freak it. Let's just pass a YAML file. So I installed the chart with this, and then so that will deploy transmission, right? Transmission pod. So here it is. I have both of them up and running. And finally, I recommend creating an ingress for the transmission pod. So this already has a service using port 80. So you use an ingress to redirect traffic from outside to port 80 on the pod, which will use port 9091 internally, which is a transmission pod, right? So let me show you what's the end result here. So you have Plex home. So this is Plex. Nothing that you ever nothing too crazy, nothing that you've never seen before. So Plex, so configure it exactly as you want. So what's cool about this is that it's basically like having a personal Netflix where you have all of your movies, all of your TV shows, right? Or you have all of your music. And it also integrates with a lot of really cool channels. So this is exposed to the internet. So you can use it anywhere where you have a network connection. So as you can imagine, I got rid of Netflix, I got rid of Prime Video, I got rid of everything. I'm tired of all of those services. The content is terrible. They keep raising prices on people, and it's just horrible. Okay, so I just figured I'm tired of that. So I want to have my own media center, right? And so that's the Plex server. And this is the transmission box. So the transmission box, so it's cool because it's gonna stay up 24/7. It has a really small footprint. It is very silent on my living room. It is also, since all of this is running on ARM machines, it is super compact. It runs super cool. Not to mention that, if I may say, ARM is just the future. So the new Apple processors, so it's ARM, and they're beautiful and they're amazing and super highly performant. So there's an AWS instance type that you can get that runs on ARM machines, and it's a lot better than x86 machines. x86 is gonna go the way of the dodo at some point, and so just get into ARM, right? And if you can get something that supports the Arch 64 standard, which is cross-compatible across all of the ARM versions, the better, right? And so this is it. So what's the point of having something like this? So transmission is also an app that you can run locally. But I don't want to keep this computer running 24/7 like a fucking savage. I want something that I can live on running, that has incredibly low power consumption, that can continue to seed and download content over time. And this does exactly what I need. And there we go. So now you have an address. You can actually even access this on a mobile phone. You can access this. Well, so this is available on the internet. This is not available on the internet because I don't need it to be available on the internet. But you could if you want it, right? So yeah, so this is really nice. It runs really great, and check it out, right? Like you can even do, of course, I cannot actually play the movie because that will get flagged, but you know, this is like super great. Plex also has transcoding, so if it detects that your bandwidth is too low, it will try to convert it on the fly to a version with less bitrate, so you can download a more compressed version, sort of what like what Netflix does, right? So this is, again, this is kind of like having your own personal Netflix, which is really, really nice, right? So, and that's how it looks. Wow, I was not expecting this video to be 30 minutes long, but you know, here we are, right? So today I covered how to stand up a cluster of Raspberry Pi machines and deploy Kubernetes, Plex, and transmission OpenVPN to them. You may wonder, why? Why not just get an old server? Why not just get a more traditional machine and just do that? Why? Because. But more seriously though, it's always a learning opportunity that you gotta, you know, take advantage of doing something like this. So it's always fun. It's just plain fun to tinker. Something that I didn't mention yet is that this has an incredibly low power draw. So this is less than 30 watts, less than keeping a light bulb on. So that's gonna be pretty great. And more importantly, again, like I said, I really like the ARM architecture, the ARM world. Again, this is nothing too crazy. You've probably seen stuff like this a million times before, but I have to report that it works and it's really great. I'm sort of trying to optimize for maximum confidence because that time of the year is approaching. The rain season is approaching, so let's optimize for confidence at this point, right? And the cool thing is that you can also scale horizontally. So my Jetson Nano, for some reason, it's not here yet. So the eBay person, so they just don't respond. So I'm gonna get one, but I can run with just 2 nodes. And when I get extra nodes, I can just scale horizontally really easily, right? So yeah, so this is it. This is really fun, right? Thanks for watching, everyone. Let me know what you think. Feel free to drop a line anytime. Again, thanks for hanging out. Yeah, have a great day.